Okay, we are now recording. Welcome to the engineering class. Before I start into the new material, I hope everybody has typed into the chat box hi, because otherwise you won't get credit for attending. Does anybody have any question about the assignment last time, the one that's due today, the Cool Inventions assignment, or anything else? Okay, I'm not seeing anything in the chat box, not hearing anything. When you guys went in to pick up your textbooks on Friday, which I hope you did, for your other classes, you may have seen that there is an engineering textbook available. We talked about that last time, but just in case you forgot or maybe for whatever reason you didn't hear it last time, the textbook that was there was not intended for your class. It's intended for my other more advanced engineering class. Did any of you accidentally pick up an engineering textbook when you were there on Friday? Okay, so I'm seeing no. All right, good. If you did accidentally pick up an engineering textbook, it's not the end of the world. But we won't be using that in this class. All right, let's talk about the homework assignment that was due today. So that was the quote unquote, the Cool Inventions assignment. I looked at the videos and other links that you guys sent me, and they were in fact very cool. And what I've done is I've posted them onto Canvas. At least I did the ones that I had as of last night. I didn't have everything as of last night. Some of you had not yet submitted them when I checked late last night. Let me share my screen here. Oops, try this again. Okay. All right. So here is my Canvas page. The engineering technology button that gets you into your class. Hopefully your button looks the same on yours. All right, so we click down here for assignments and quizzes and tests and things. Hello. Boy, my internet seems to be running slow today. Hang on a sec, I gotta. Hopefully I muted myself before I sneezed there. Okay, so here are the things in the engineering tech class. If you look on Canvas right now, you'll see there's a link here that wasn't here last week. It says what you guys submitted for the Cool Inventions assignment. So if I click on that, it takes me down to this. So these are, so basically I just collected everything into one place. Let's just talk briefly about these. I don't want to actually play all the videos. I would definitely overwhelm my internet connection for sure if I tried to do all that. But let's just talk briefly about it. Okay, this one here, okay, right. This was a faucet that was temperature sensitive. So when cold water was coming out, blue light would shine. And then when hot water came out, it'd be red light, and somewhere in between, it was in between. That was very cool. Well, actually they were all cool, but I really liked that one. Okay, this one was a biomedical scanner. I think you can see from here, it's kind of like an MRI machine, but allows doctors to see what's going inside your body. That's very cool. Okay, this one here, oh, this was awesome. I really like this one. Let's see if I can find a place. Okay. Okay, this one, they have this dartboard, and it's on a track so it can move up and down according to computer control. And so there's a camera that watches when they throw the dart. And so they don't even have to aim. They just throw the dart any old direction, and the camera analyzes the flight of the dart, and it predicts where the dart is going to hit, and then it moves the dartboard so that it always hits in the bullseye. That was a really awesome, and I love that. I mean, they were all good, but I especially like that one. That was very good. Okay, let's see, what do we have here? Okay, this was the electric mosquito trap. Okay, so mosquitoes get pulled into here and they can't get out. What else do we have here? Oh, the titanium lightsaber. Okay, that one's a really long one. Let's see if I can find. Okay. Yeah, I'm not going to be able to find the one I want there. So that was very cool. Okay, what do we got here? Oh, the levitating light. Yeah, well, you can see from the picture there. So this is a light bulb that just floats, and when you touch the wood, it lights up. And then I got 2 people submitted the same link on that one. Okay, this was a collection of 10 different inventions. So the person that submitted this one, what they just did was they picked which one of the 10 was the one that they liked the best. So I'm going to skip over that. This one here was a motorcycle.
Excuse me. Sorry, I had a hard time getting into the Zoom room. What did I miss?
We're just talking about the homework assignment. So people submitted their links of the inventions that they thought were cool. So we're just going through those. Right. I'm not actually playing all the videos. We don't have time for that. But this one, it's a motorcycle that also floats. So you can drive it on land, and then you just drive it into the water and it floats, and you turn on the jet ski and off you go. Very cool. This one here was not a video. This one was a website that talked about the Burj Khalifa, which is in fact, it is the tallest building right now. There's others under construction, hoping to beat it, but right now it's the tallest one. Okay, and so on this website here, it just talks a little bit about Okay, my Zoom software froze. It actually rebooted on me. How long was I gone? Was it just for a minute, or was it for more than that?
Yeah,
it was like 10 seconds.
Yeah, it wasn't
okay.
long.
All right. I wonder if we're still recording. Okay, it looks like we're still recording. Okay, so my internet connection here at home obviously can't handle all of that. So I'm going to get out of that page. I'm going to go back. I think I just tried to load too many things all at once. So anyway, if you guys are interested in seeing what everybody submitted, just go and click on this cool inventions thing here. This is not an assignment that you need to do. It's just a collection of the assignments that you already did. So a couple of things that we should talk about there. In fact, tell you what, you guys maybe don't even see my screen. Am I still sharing my screen? Oh no, I'm not even sharing my screen anymore, am I? Boy, when I rebooted my computer, it reset everything. Okay, well anyway. Okay, a couple things we need to talk about. Some of you did not get full credit for the homework assignment. The reason that you didn't was because you were missing something. Like for instance, some of you uploaded the video or the link, but you didn't list all of the different engineering fields that were involved in creating that particular invention. That was part of the assignment. So I had to take off points for that. And not only were you supposed to list the engineering fields, but you were also supposed to describe what the engineering disciplines did. Like for instance, if your invention had some sort of an electrical component, you should have said, the electrical engineers designed the computer that controls this and that, and the mechanical engineer designed the wheels and the motor, and the materials engineer decided what, all that kind of stuff. That was part of the assignment. So if you didn't list the fields, or even if you did list the fields, but you didn't give me a sentence or two for each one of the fields telling me what they did, then I dinged you some points for that. Now, I wasn't expecting a whole paragraph for each one of the engineering fields, but I was expecting a sentence or two telling me about it. So if you look on Aspire or Canvas, I haven't transferred into Aspire yet, but if you look on Canvas and see you got anything less than a 10, that would be why. What else do I have here? I think that's pretty much it. Now, some of you did not even turn in an assignment at all. Most of you did, but one or two of you didn't. I hope you guys realize from reading the disclosure statement that I only allowed 2 late assignments. Now, I do allow 2 because I do recognize that, hey, you know, things happen. Unavoidable.
Oh, hold on. I got a quick question. Did we have school on Friday?
Yeah, let me finish what I'm saying and then I'll
Okay,
get back to that.
my bad.
But that is an important question. So back to the late assignments, I allowed 2, and some of you have used up one of your 2 assignments already. So if when I give an assignment, it's always due at 2:15 on whatever day I tell you. So like, for instance, the assignment that was due today, if you try and slip that in right now, hey, sorry, Canvas tells me what time you submitted it. And if it comes in anytime after 2:15, it gets marked as late. But now I will give you credit for 2 late assignments, but only 2. And after that, I don't give you credit for your late assignments anymore. So you need to make sure you get them in on time. All right, so let's talk about Brandon's question. That is an important one. So his question is, did we meet on Friday? Well, yeah, here it's kind of complicated. Last Friday was officially an A day, but we didn't hold any of our A-day classes. Fridays are intended to be individual study days, and also days where teachers can be available to help you one-on-one over Zoom or whatnot. But it still counts as an A-day, which you guys have obviously figured out, otherwise you wouldn't be here right now. So we met on Thursday. Friday, I did not meet with my A-day classes. Here it is Monday, I'm meeting with you guys again. So yeah, this makes things a little bit complicated. It's not the ideal way to do things, but we have no choice because we have to follow the Cottonwood schedule. We've got so many AIM students who are taking Cottonwood classes. We have to follow their schedule, even when their schedule doesn't make sense. All righty. Okay, I am ready to launch into today's assignment unless there are any other questions.
Yeah, sir, I have a question. So my question is, so you said that you wouldn't give credit for any missing assignments. So like if we miss something, does that mean we can't make it up? Is it just gone?
No, that would count as your late assignments. That's what I just
Oh,
got through
okay.
talking about. So if you didn't
All right.
turn something in, okay,
Yeah.
and then you say, oh my goodness, I forgot. And so then you turn it in after the deadline, I will accept it,
Oh, okay.
you know,
Okay.
but only twice.
Okay.
You know, I'll give you credit for the first 2, but after you've used up your late passes and you turn in that 3rd one late, I'm going to say sorry.
Yeah. Thank you.
Okay. All righty. So let me get my Canvas page open. What I'm going to do is I'm going to go into Canvas again. And then I'm going to share my screen. Yeah, my internet is definitely running slow. I can understand why it got locked up here. Boy, it's just super slow. Holy cow. It's not responding at all. Oh, there it goes. Okay. All right, so now I'm going to share my screen. All right, so hopefully you guys are now seeing my Canvas screen. It should look similar to yours. You're going to have different icons because you got different classes. So here's the engineering technology class. So I click on that. And eventually it will open up. Eventually, come on. Okay, here it goes. All right, so I scroll down to the bottom, click on the assignments page, and eventually it'll open up again. All right, okay. So this thing at the top, you're not going to have that in your class. So my teacher's version of Canvas looks different than the student version. All right, down at the bottom here, the engineering design process, part 1, functional specification. That is tonight's homework. So let's click on that and go in and look and see what we see there. All right, so what we have, this little circle thing that you see here, let me make it a little bit bigger so it's a little easier to see. This is what you find in a lot of engineering textbooks. This is what they call the engineering design process. So when engineers are given some sort of a problem to solve or some job that they need to accomplish, this is a generic representation of the steps that engineers go through in solving the problem or designing a solution or whatever, in doing the job. This is a process that you guys need to know, because this is what we are going to be using. This is what I want you guys to do every day or every time that I give you some sort of an engineering problem to solve. So today we're going to start into our first module, our first engineering field. I'm going to give you some problems that you need to solve, something you need to create. And this is the way it's going to go all year long. So we're going to start with the field of engineering called aeronautical engineering. And we're going to spend about 2, maybe 3 weeks working on some sort of an engineering project where you're going to have to design something, you're going to have to make something that's in some way related to engineering. And these are the steps that you're going to have to go through in order to do it. And then at the end, we'll wrap it up, and then we'll go into the next field, and we'll spend 2 or 3 weeks doing something else, maybe electrical engineering, and then we'll move on to something else, maybe mechanical engineering. So as the semester goes by, we will get some hands-on experience to let us know what the various engineering fields do and how engineers solve problems. Now, this class is only a semester-long class, so we can't go into all of the different engineering fields, but we'll try to hit the interesting ones. And so each time I'm going to give you a problem you need to solve or a job you need to do. And the process that you see here, this is the process we need to follow for each one of these problems. So let's talk about it. And by the way, I suggest you take notes, because what we're going to talk about here will be you will be tested on these. You do need to know them. All right, so let's start with the first rung here. Number 1 here, it says define the problem. Okay, so pretty obvious. Before you can solve a problem, you need to know what the problem is that you're trying to solve. You need to know what are the limitations. What materials can you work with? How much money are you allowed to spend? And what is the things that, whatever it is that you're trying to build, what is it supposed to do when you finish building it? Okay, so define the problem is the first step. Now, at the end of this step, we have what I like to call a deliverable. Okay, and that's a document that you have to produce. So forgive me if my handwriting is bad because I'm using my finger. I don't have a pen. I need to get one. I had one, but I lost it. Okay, specification. Boy, that's terrible. Okay, so that's supposed to say functional specification. So that is the name of the document that you need to produce. And we're going to, later on, 10 or 15 minutes from now, I'm going to pretend to be the customer. You are the engineer representing your team. We're going to meet together, and I'm going to verbally describe to you the job that I want you to do. And I'm purposely doing it verbally rather than in writing, because if I were to write it all up, well, then you'd have your functional specification already done for you. And that's not good. It's your job to write out the functional specification, not mine. So I'm going to give it to you verbally. I'm going to describe what I want you to do. And I might accidentally, wink, forget to include some of the important information that you need to know in order to do the job. So if you think that I have accidentally, forgotten some important information, it's your job to ask questions and pull the information out of me. It's your job to think, what do you need to know in order to do this job? Okay, and then at the end of our conversation, you then need to sit down and write up a description of everything that I've told you about what the thing is supposed to do and what are the limitations you have and all of that. That document that you create is called the functional specification, and that will be your homework for tonight. That will be due at 2:15 next Wednesday. Okay, that's your deliverable. All right, and now when we do this little pretend scenario, we're going to pretend that the only people in the room are you and me. But you are actually just representing a much larger engineering team, because almost any major problem that needs to be solved in this world, it takes a whole team of engineers. Like if you're going to design an airplane, it takes hundreds of engineers. But if you don't want to send all 100 of those engineers to sit down and talk with the customer. If you got 100 people on that side of the table and only one person on this side of the table, it's really intimidating. And you don't want to intimidate your customer. So you are the one representative from your team. And so it's very important that you write up a clear, complete, concise explanation of what the problem is, because you're going to then give that document to your team members, and they need to be able to read this document, and this document needs to have all of the information that they need so they can create the solution, right? So that's going to be what we're going to do today. But let's talk about the other steps in the engineering process as well. Step 2 is brainstorm. Now, brainstorm is a word that I hope that you guys have heard before. Anybody want to unmute yourselves and tell us what does it mean to brainstorm something? If you hold down the space bar, as long as you keep it held down, you'll be unmuted.
Means you come up with ideas and it's like a starting plan almost.
Okay, so you come up with ideas. All right, so what's going to happen here is that you as the engineer who have met with the customer, you've written up your functional specification, you've given it to all the engineers on your team, so you're going to get everybody together in a big room without the customer. The customer's gone now. So all your engineering team, you get together in a big room and you just throw out ideas. You say, well, maybe we could solve the problem like this. And somebody else says, maybe we can solve it like that. And so you're going to write all these ideas on the board. And there are rules for when you're brainstorming. And one of the rules is don't reject any idea. Because what's going to happen is somebody in the back is going to raise their hand and they're going to throw out an idea, and whoever's at the board writing them down, they might be tempted to say, oh, that idea won't work. No, don't do that. When you're brainstorming, you capture every idea, even the ones that you think may not be the great ideas. So write everything down on the board. That's the brainstorming process. Just toss out ideas. Crazy or not, everything gets recorded. Okay? And then after you've brainstormed, then you hopefully have at least 12, maybe more different possible solutions. What you need to do now is you need to narrow it down. Okay, so step 3 in the book here, or step 3 in this little chart here, is research and generate ideas, which is basically you've got all these ideas on the board from your brainstorming session, and you do a little more research into each one of them. What would it take if we were to do this solution? What would we need? How much would it cost? Is it even possible to do it that way? That's going to take some time to research that out. So this is something that happens after the brainstorming session is over. Okay, and the idea is we want to take this list of 12 or 15 ideas and we want to narrow it down to the best 3 or 4. Okay, and so that takes some research to do. Now, step number 4 in the wheel here is one that I think really should be part of step number 1. Okay, if you were to ask me, I would say step number 4 and step number 1 they really go together. Okay. When you're defining the problem, one of the things that you need to define is what are the constraints. Now let's make sure everybody knows what the word constraints means. Somebody unmute yourself here and tell me what is a constraint?
Like a drawback, or like something that will prevent you from doing the thing.
Okay, it's some sort of a limitation, something that would prevent you. Like for instance, maybe money. Okay, maybe you're only allowed to spend, $1.5 million. And so when you look at the brainstorming ideas, you see something that looks like it'd be a really good idea, but when you do the research, you find out, well, if we do that, it's going to cost us $4 million, and we've only got $1.5 million to spend, so we're going to have to rule that one out. So a constraint is a limitation. So money, or maybe certain materials, you're only allowed to use certain types of materials, or similar types of limitations that are placed on you. So in my opinion, that is something that should have been defined back in step number 1. So the people who wrote this design process, maybe they're thinking of this differently than I do. So if I were to make mine, I would do this cycle slightly differently. Okay, step number 5, in my opinion, is really part of step number 3. That's we're researching, we're exploring the different possibilities. We're trying to narrow this list of 12 to 15, narrow down to 3. So in my opinion, step number 3 and step number 5 really go together. So if I were to ask you on a test, you wouldn't have to duplicate this exactly. All right. Now, step number 6, select an approach. All right, so we started off with our brainstorming list of 12 or 15 possible ideas. We did some research, we explored the possibilities, we narrowed it down to like 3 or 4, and then we do a little more research, a little more exploration. So at some point, we need to narrow it down to one idea. We need to decide what's the one approach that we're going to actually do. All right, important part of the engineering design process. All right, next, we need to develop what the people who wrote this chart, what they call a design proposal. Now, when I was an engineer back in Silicon Valley, and we did this kind of thing, we had a name for this type of thing. We called it a functional specification. So functional, oops, wait a minute. I'm sorry, that was the first one. The first deliverable is called the functional specification. Okay. The second deliverable, that's the document that you have to produce when you get to step number 7. Okay. That one is called an engineering specification. At least that's what we called it at the companies where I worked. And I worked at a couple different companies. Oops, that's terrible. Let's try that again. Oops. Boy, I'm just not having good luck here at all. Okay, try that again.
Wait, and so what was it? Was it just developing a design for the product?
A design for the prototype, which is really the product, yeah. So let's say that the job you need to do is to build something, which, by the way, that is what your job is going to be, is to build this something. Okay, all right. So the first document that you need to produce is the document that you produce after step number 1. This is the document that describes what it is you need to do, what the constraints are. We called it a functional specification. Other engineering books, they call it a design problem. Okay, then the second document that you need to produce is what me and my colleagues, we called it an engineering specification. And some books call it that, other books call it a design proposal. Okay, but basically it's a description of how are you going to solve the problem. What are you going to make it out of? How are you going to put the pieces together, and how are you going to control it? Basically, it describes how are you going to do the job. So the functional specification does not, describe how you're going to do the job. The functional specification only describes what the job is that you're going to do. And in fact, when you guys write your functional specifications for tonight's homework, there's a couple of rules that I'm going to put on you. There's something that you must not put in a functional specification. And what that is that you must not include any hint as to how you're going to do the job. You should only describe what the job is. Don't describe how you're going to do it. Now, let me give you an example that'll hopefully make it clear. Okay, so in past years, one of the projects that I've given to people is you've got like a little ball, say maybe a ping pong ball or something, and you've got a cup. And so, in fact, let me stop sharing here so you can see a little better here. Hopefully you can now see me on the full screen. If you can't, click on the upper right here. You know, you've got gallery view and you've got speaker view. So in the upper right, click it on speaker view, and you should be able to see a lot better. And I used to have a little ball. Okay, it disappeared. So let's pretend that this is a ball and here's a cup. All right. So one of the things that I've done in previous years is I tell people, okay, we got this ball and it's sitting here on the table at a certain place. We got this cup that's sitting on a table at a certain place, and your job is to make a device that can get the ball inside the cup. Okay. Now, a lot of times when people wrote up their functional specifications, in the functional specification, they talked about a hand picking up the ball and putting the ball in the cup. That's not good. I took off points if they did that, because in the requirement that I gave them, at no point did I say it had to be a hand. All I said was that you got to get the ball in the cup somehow. I don't care how you do it. You just got to get the ball in the cup. So in your functional specification, if you go into specifics and you say, well, you need a claw to pick it up, no. What you're doing is when you do that, you're narrowing the thinking of your team members. Remember, this is the document that you're going to take back to your company and you're going to share with your team members. And so if you use words like hand or claw or anything like that, already you've narrowed their thinking, and you don't want to do that. You've got a team of very intelligent, very creative people. Let them run with it. You never know. Maybe what they'll do is they'll build a little ramp and they'll push the ball up. Or maybe, you guys have all seen Star Trek, right? You know that they've got this cool transporter device where they push a button and you just disappear here and then you reappear there. You know, maybe somebody on your team can design a Star Trek transporter that just magically transports. See, so don't restrict their thinking. Okay, so the functional specification should only talk about what is the job that needs to be done. It should not say anything about how you intend to do the job. Now, at some point, it is important to talk about how you intend to do the job, okay? And that is going to be when you get to step 7 of your engineering design process, okay? So when you get to step 7, that's when you produce what I'm going to call the engineering specification. I'm not going to bother spelling it out, okay? That's the document that describes how it's going to do the job. Okay, and you will be required to do one of these, but not this week. That'll be something that'll be due next week. For this week, the only thing that you need, actually for tonight anyway, the only thing you need to do is do the functional specification. So as soon as we finish talking about the engineering design cycle here, then I will take off my teacher hat and I'll put on my customer hat. I will pretend to be the customer, and then we'll sit down, we'll have our conversation. So hopefully you'll have enough information that you'll be able to come up with a good functional specification. But hold off just a few more minutes for that. Now, by the way, if any of you have questions, I'll gladly take them. So I do see the one question where you're asking what companies did I work for. They were companies that you would never have heard of. Yeah, I don't want to go into too much. I mean, I can tell you the name. One of them was called KLA, and the other was called Applied Materials. So I'm sure you've never heard of those. Maybe later when we have time, I'll talk about them, but not right now. Okay, so step number 8, after we've got our engineering specification written up, so this is the document that describes how we're going to solve the problem. Well, now it's time to get to work and solve it. Now, the first version of our creation is called a prototype. A prototype is something you don't worry about making it perfect. You don't worry about making it pretty. You just want to make it fast. And so you throw this thing together and you test it out. And you see, does it have any hope of doing the job? Okay. Hopefully it'll work, but it might not work quite as well. Like, let's say that you do decide to use a hand, right? Maybe the hand doesn't quite hold it well enough. And so maybe you only started with 2 fingers and then you say, oh, well, we need more fingers. Don't be surprised if your first prototype doesn't quite work the way you want, but you'll learn a lot by making your prototype. And then what you're going to do is step number 9 here. You're going to test your prototype. You're going to find out, well, it didn't work quite as well as we want. So we're going to refine it. So we're going to come back with revision, version 2 of a prototype, and maybe even version 3 of a prototype. We may go through several versions, but eventually we'll get our prototype to where it does what we want to do. Okay. Now we're ready to do the final product, step 11 in the cycle here. This is where we make the actual thing that we're going to deliver to the customer. Now here's where we do need to make it pretty and make sure that all the sharp edges are all smoothed down. So that's the final product. Now, if what we're building is something like a bridge or a building, we're only going to make one of them. But maybe what we're building is something that we're going to take to a store and we're going to sell millions of, so we're going to mass produce it, But we don't do that until after we've worked with the prototype for quite a while and gone through several versions, and we've got a prototype that we're actually happy with. All right, now a lot of students think that when you've done this, you're now done and you're ready to go on to the next project. Well, not so fast. Step number 12 here is really important. Step number 12 is we have to communicate the results. So this is what I call the third deliverable. It's the third document that you need to create. This is the final report. Okay, so final report. Okay, this is where you write up a document that describes everything you did, talks about the prototype, talks about the fact that the first one didn't work, and so this is what we had to change. It sums up everything. And so when we do these little projects where we spend 2 or 3 weeks doing an aeronautical engineering and we spend 2 or 3 weeks doing something else, okay, at the end of each one of these little modules, you will need to do a final report. That'll be kind of like the final exam is in some of your other classes, right? So there's 3 documents that I need from you for every project that we're going to do all semester long. I need a functional specification that tells me what the goal is, okay? But it does not tell me how you intend to meet the goal. That's your first document. Second document is the engineering specification. That's the document that tells me how you intend to meet the goal. And then the third document is the final report. So get used to these. You're going to be writing a lot of them. Okay. Now, are there any questions here? I'm not seeing anything in the chat box. Questions, yay, nay? All right, let's go ahead and start. Okay, so I am now going to pretend that I'm the customer. And you are going to pretend that you are the representative from your team who's going to sit down across the table from me, and just the 2 of us are going to talk. And it's your job to make sure that you fully understand what it is that I want from you. Make sure that you fully understand what are the constraints that you have to work within. And if I accidentally forget to include some important information that you need to know, it's your job to pull that information out of me, okay? All right, so before we start, I see Tafua has asked, how long was the functional specification? Well, it depends. I mean, however long it needs to be. Today's assignment is a relatively simple one. it could theoretically be done in one page, but maybe two. It depends on the circumstances. So let's talk about the job that needs to be done, and then maybe you'll have a better idea on how long you think it needs to be. All right, so teacher hat goes off, customer hat goes on. Thank you for coming and meeting with me today. I'm hoping that your company will do a good job at the thing that we want to build. Please be aware that I am interviewing other companies as well. And I'm going to have several different companies competing against each other. So whoever does the best job, they're the ones that are going to get this contract. And it's a multi-million-dollar contract. So make sure you do a good job. Otherwise, you'll lose out on it. Here's the deal. What I need you to do is to make a paper airplane that can fly very straight, very accurately, and land near a target. And so what I'm going to do is I'm going to have you take like a coin, like a bottle cap would work, or a coin. Let's think of it as a coin. So we're going to take a quarter, and we're going to set the quarter down on the ground. And then you are going to back up so that you are 15 feet away from the quarter. And then you're going to take a paper airplane, which you need to design. You can do it any way you want. I don't care, as long as it's an airplane. It has to have wings, so it has to fly. You can't just take a piece of paper and wad up the paper and throw the paper. That doesn't work. It has to look like an airplane. It has to have wings. And so you're going to stand 15 feet away from this quarter that's sitting on the floor. You're going to toss the airplane. It's going to fly through the air, and I want it to land as close as possible to the quarter. Okay. And like I say, you're doing this job, and I've got other companies that are also doing the job. And whoever can get me an airplane that can fly the most accurately and land closest to that quarter most repeatably, they're going to get the job. And so what I need you to do is I need you to give me the design for how you make this airplane. Because as I'm sure you've learned, there's hundreds, if not thousands, of different ways you can make paper airplanes. So you need to find the design for an airplane that does the job the best. And then you need to give me the designs so that I can then mass produce these paper airplanes and sell them for millions of dollars. So that's the job that needs to be done. Are there any questions you want to ask to better understand the problem or the limitations?
Yeah, sir, I want to ask a question. So when you say it has to look like an airplane, can you specify what you mean by airplane? Do you mean as a common paper airplane that we see in like the internet, like in TV shows or anything, the common airplane, or do you mean like an actual airplane that flies in the air?
It needs to fly through the air, but it doesn't have to look like the kind of airplane that people get in and fly in around the world. I mean, it can be a really simple, just, take a piece of paper and just fold it up. As long as it has wings, that's all I care about. It has to have wings. Now, the reason that I say that is because I'm sure that some of you are going to be tempted to just take a piece of paper, just crumple it up, and then just toss it, and then see how close you can get to the quarter. So I'm not going to allow that, because that wadded up piece of paper, not really an airplane. It doesn't have wings, see? So I need something that has wings, something that actually floats through the air.
What if it's a wadded up piece of paper with wings?
As long as it's got wings. I mean, as long as when I look at it, if I see that those wings could potentially support some of the weight of the thing, I would go along with that. But it's got to have wings.
Does what kind of paper we use matter?
Yes, I'm glad you asked that. That is important. That's something that I accidentally forgot to say. Okay, so it needs to be a standard type, printer paper. It needs to be 8.5 inches by 11 inches, and it needs to be normal thickness for printer paper. I know that you can buy special thick paper. They call it card stock is what they call it. But I don't want you to use card stock. And don't use that super thin stuff. Just regular weight printer paper.
Is
Other
there any
questions?
materials that we use?
Other than the paper? Okay, very important question. Glad you asked that. Yeah, some of you might think, well, is it okay if I add a paper clip in order to give it a little bit of weight? Or is it okay if I staple it? Or how about tape? Could I put tape on it? And the answer to all those questions is no. No staples, no tape, no nothing, no glue, no nothing. The only thing you're allowed is just paper. That's all you're allowed. Anything else?
Okay, my question was, how big will the target be? Will it be huge or will it be small?
Well, the target will be a quarter.
A quarter, okay.
So what you're going to do is you're going to set a quarter down on the ground. You're going to back off 15 feet. You're going to toss your paper airplane. It's going to fly through the air and land near the quarter. And by the way, if it bounces a couple times, well, you know, wherever it ends up, that is, that's what you're going to measure. And so I want you to, and I want you to imagine that there's a little dot in the very center of the airplane. And you're going to measure the distance from the center of your airplane to the center of the quarter. And so whoever can get it the closest repeatably, okay, if you just do it one time, that doesn't count. It has to be repeatably. Then you win this multi-million-dollar contract.
Does it matter what conditions you do it in?
What do you mean?
Like if it's windy?
Oh, okay. Well, it's up to you on that one. I would certainly recommend that you don't do it when it's windy. That's going to make it almost impossible to get good repeatable results. Now this, the distance that I chose, 15 feet, I purposely chose that so that you could do it indoors. Ideally, if we were back at Ames right now, I would go into Skunkworks and I would make the distance be a lot bigger. I'd make it be like 25 or 30 feet, which we could do in Skunkworks. We have enough room there. But I realize that if I make it be 25 or 30 feet now, a lot of you, the place where you're living, you may not have a room that's that big. And so then you'd have to go outside. And then if you go outside, then you got the wind and that's going to mess everything up. So I purposely made the distance shorter than I normally would in order so that you can do it inside. But hey, if you want to do it outside, hey, more power to you.
How many times do we have to repeat that? Repeat the throw of the plane, or?
3 times.
Okay, 3 times, right?
Yeah. And so
doesn't matter what condition the paper is. Like, can it be wet or dirty or kind of beaten up? Doesn't matter.
Well, let's say it cannot be wet. As far as dirty goes, well, I mean, if it's got visible dirt on it, that would be a problem. I mean, if it's got some drawings on it, I'm okay with that. But yeah, dirt would add weight. That would be a problem.
Does it matter how many pieces of paper we use?
Yes, it does. You're only allowed 1 piece of paper.
Is there anything else that we should take into account, like maybe who's throwing it, the height of the person, or can we stand on something?
You can do all of those things. You can let anybody throw it that you want to throw it, but it should be the same person who throws it every time. So if you design something that works really well when a short person throws it, then make sure that a short person throws it. Because if a tall person comes along and throws it and it doesn't work so well, yeah. So keep that in mind when you're designing it, and always have the same person throwing it.
Does the flight time of the paper airplane matter?
The flight time of the paper airplane does not matter.
Does how you throw the airplane, does that matter?
No, you can throw it any way you want. But you can't scoot it across the floor. I mean, it has to actually go through the air. If you put it on the floor and just kick it, then it's not really flying. It has to actually fly.
What if you're hanging from a ceiling 15 feet in the air and drop it?
I wasn't anticipating that one. Well, that's a clever idea. I'm going to have to say no to that one, but I give you points for being clever there. I do like that. A couple other things. I can think of one important question that you guys haven't asked yet, but I don't want to ask it for you. Let's see what anything else.
When do you want it? When do you want it made by?
Next week. We're going to talk more about that when we meet on Wednesday. Right now, the only thing right now the only thing that you guys need to do is the functional specification, and then on Wednesday we'll talk more about when the actual airplane has to be made. But bottom line is it's sometime next week.
How are we going to be submitting it? Are like we sending a video or a picture, or how are we submitting if we won or not?
Okay, I'm very glad you asked that question. All right, what you need to do is you need to submit a video of you throwing the airplane. And so what you're going to do is you're going to get out your cameras. Okay, and so you're going to throw the airplane and you need to follow the airplane as it flies, and you need to show it landing, and you need to measure it, and it all has to be in one take. I don't want any editing done here, because if I let you guys edit it, then it's very easy to cheat. So I'm not allowed that. So I need to see you throw the airplane, fly through the air. I need to see it land, and I need to see you measure how far it is. And so that is one of the things you're going to need to do for your final report. And also for your engineering specification, I need to see a step-by-step procedure for how to fold the paper to make your airplane. You need to give me enough information so that I could follow your instructions and I could make an airplane that's identical to yours. So I need, and this is something that you might be tempted to do it as a video, but I don't want you to do it as a video. I want you to do it written instructions with pictures saying, you know, fold here first and then fold here and then, you know, okay. So those are the two deliverables that I'm going to want.
When you pick the idea for mass production, what do you want the cost to be? Like, what would that price range be at?
Just the cost of a piece of paper. So don't worry about cost on this particular project. You know, it's just one piece of paper, whatever it costs.
You said the final distance is wherever it ends up compared to the quarter. What if it hits the quarter and then bounces off?
Then you should measure from where the quarter was before the quarter got pushed away.
Well, no, I mean the airplane hits the quarter and then the airplane bounces off of it.
Oh, okay. So you measure to wherever the airplane ends up.
Okay.
What should you do? Well, like, how would you measure it if like the airplane lands directly on the quarter, like, because like it's covering it up?
Yeah, then that's going to make it a little bit tricky, but you need to estimate the distance from the center of the airplane to the center of the quarter. And so if the airplane is covering up the quarter, yeah, it's going to be a little tricky there, but I'm sure you can figure out a way to do that.
Are we allowed to base off of like any other, like if we watch like a video on like how to make airplanes, or like what ones would work best for something similar to this? Are we allowed to like base off of that or copy that?
Not only are you allowed to do that, but in fact, I encourage you to do that. This is one thing that engineers need to realize is you don't need to keep reinventing the wheel. That's a phrase that I hope you've heard many times. There are lots and lots of great designs out there for airplanes. So yeah, by all means, use those designs. You don't need to create something new from scratch. All right, there's one question that nobody's asked yet, so I will go ahead and ask it for you. The question that I would hope you would have asked is, are you allowed to cut the paper? The answer to that question is yes, you're allowed to cut slits in the paper. You're not allowed to cut pieces out. I mean, like if you wanted to cut off a corner and throw away the corner and just use the rest of it, no, that's not allowed. You have to use the entire paper, but it's okay to cut slits in it if you want to do that. And it's okay to fold things any way that you want. You just can't remove a piece and throw that piece away. That's not allowed. Any others?
Maybe this was already asked, but how many times were we allowed to throw it? Like how many times is
I want to throw it 3 times.
3? Okay.
Yeah. And so what we'll do, you can throw it as many times as you want. If you want to throw it 100 times and then just keep your best 3, I will allow that. Okay. So if you take 100 different videos and throw 97 of the videos away and only give me the 3 good videos, that's acceptable. In fact, that's what I want.
Are we allowed to like test it and then as we test it, edit or like make changes to the plane to make it fly better?
You are encouraged to do that because that is what engineers do. Very rarely does your first prototype work out the way that you want. So yes, by all means, if your first airplane doesn't work the way you want, scrap it and get an entirely different design. Yes, you can do as many revisions as you want. Okay, we're running a little low here on time here, so let's cut it off. I think that you guys have enough information now so that you can write up a good functional specification. So remember that next time we meet on Wednesday, you don't need to have your airplane ready at that time. The only thing you need to have for Wednesday is your functional specification. So let's remind you what a functional specification is. A functional specification is the document that describes what is the job that needs to be done, what are the constraints that you need to work within, okay? And a functional specification does not say anything about how you intend to do the job, okay? That how you intend to do the job, that's part of a different document. That's part of the engineering specification, but the engineering specification is not due on Wednesday. Only the functional specification is, okay? Last chance for questions.
The functional specification, that was supposed to be like 2 pages, you said?
Well, it doesn't have to be. If you wanted to cram it all into 1 page, you might be able to do that. Something like this, most people would take somewhere between 1 and 2 pages. If you take more than 2 pages, then you're going into too much detail. If you only take a half a page, then I doubt that you're doing a good job on that.
So like when you say 1 whole page, do you mean like do we have to include like literally, so we include basically everything? Because 1 page is like it's a lot compared to like what you said. So like would we have to like go into a little bit more detail?
Use your judgment.
All right.
Remember, the way I'm going to grade this is I'm going to look at it and say, okay, let's pretend that I'm one of the engineers on your team. I was not in that meeting that you had with the customer. You were the only person that met with the customer. Okay. The only thing I have to go off is this piece of paper that you're going to give me that's called a functional specification. And so I'm going to look at it and say, is there enough information on here that I, as one of your colleagues, could read this and fully understand what is the job that needs to be done and what the constraints are. That's the way I judge it. Okay.
And can you write it in bullet points or full sentences?
I'll leave that up to you. Okay, I think that we're ready to call it a day. Now, I want to take roll one more time. Before you guys leave the meeting, please, in the chat box, please type bye or something similar. And then once you've done that, you can go ahead and leave the meeting. If any of you have other questions you want to talk about one-on-one, I'll be glad to listen to you. And if you want, I'll turn off the recording. Because if you have a question that you might be embarrassed about, I'll turn off the recording so that nobody will hear it other than you and us.
Thank you so much.
Hey, my pleasure.
Bye.
Bye. Okay, so I'm going to turn in the recording now.